I mean, relevance realization at its heart is not a principle. It could be expanded
Yeah,
to be
yeah.
a principle of physics but really fundamentally it's a process theory. And what I mean by that, I mean in the same way that active inference is a process theory. What does that mean? It means that it's an account, it's a theory of how certain functions are fulfilled. So relevance realization is also, if you actually decompose it, has these so-called oppositional processing, explore, exploit, for example, dynamics, which John proposed, and this is before active inference, so I think this is sort of 2011, 2012, that these kind of oppositional dialectics, when they're working in concert, yield relevance realization. So he's actually giving an underlying process to a higher order cognitive capacity. Now, the free energy principle doesn't do that. The free energy principle doesn't actually tell you anything per se about what exists. It just says that if things exist over time, they look as if they are conducting variational Bayesian inference over their external states. They look as, and that is if they are to persist. So if you, Jack, today are going to be the same Jack as you are tomorrow, then anything that you do, as long as that identity remains the same, can be described in terms of Bayesian inference and optimal Bayesian design. So the free energy principle itself, and Carl will say this, is actually in many ways slightly empty because it doesn't really tell you anything that actually happens. But then you get active inference or predictive processing or variational message passing, or you get these POMDP schema. And now you start to see, okay, how could this actually be implemented in complex cognitive creatures like ourselves with hierarchical brains, literally anatomically hierarchical, ridged brains. And then you can start to make empirical predictions. So I only say that because I think there's just a slight difference in a way between relevance realization and free energy principle. The free energy principle just tells you, well, we all have to obey by the free energy principle in somewhat of a boring way. Where the money really is given that, how do we obey by the free energy principle? How do we abide by the free energy principle? And then you start getting the process theories like the Bayesian brain hypothesis or predictive processing.
Ah, I see. So that's really helpful. And then can I just probe into
Yeah,
that? And if
sure.
I'm just trying to understand this correctly, with the free energy principle and it being something which is kind of a tautology and it's not necessarily interesting in and of itself. I might be again conflating the free energy principle, this more base structure and theory, with applying that to cognition, like with predictive processing.
Yeah.
But surely there are ways in our cognition that we can be sort of out of sync with the world for prolonged periods of time, and in such a way, and maybe this is getting into like how psychopathologies work, but if you know what I mean. And so sometimes it seems to me that predictive processing would be like, on average, in equilibrium, you must be coupled with the world, unless you die or you're gonna
Right.
you end. But then maybe you're saying to be exactly the same. I guess we're always changing, and like you could
Yeah, so there's no you don't have to invoke something like a fixed state space in active inference. So this is there's a couple of things here which are relevant. So one is that you don't have to say the same thing over time. So this is the so-called path integral description of active inference, which is that basically it's a probability distribution over the path of states, not a probability distribution over states themselves. So that's one distinction, which allows for this kind of itinerancy over time, that you're tending towards something, but you don't have to be there right now. I mean, that actually lends itself to the other thing, which is that we're always talking about probability distributions, which doesn't mean that you always need to be at the peak of your probability distribution. If you've got a Gaussian or just a bell curve, you don't always have to be at the top of that bell curve. The point is, over time, you will like if I flip a coin 100 times, 50 out of 100, it might not actually be that, but it will tend to that distribution, right? And if I do that infinitely many times, then it will be that distribution. The idea is that you can think, over this set period of time, at least I have this probability distribution that I'm tending towards. And this is why people talk about an attracting state. But you don't have to necessarily always be in your attracting state, right? If you can always just be described as tending towards the attracting state, given the thing that you are. Which actually brings me to my next point, which is that you mentioned psychopathologies, which is a really interesting thing. Remember that you and I are not the same thing. Like, you and I are not composed of the same Markov blankets. You and I are self-evidencing for our own models, but they're not the same model. Now, they might be very similar because we're both Homo sapiens, we speak the same language, and so on, which means that we're more similar than, let's say, me and a turtle. But there's still going to be differences. What active inference what free energy principle really tells you is that given, if I can write down what you are, then the action that you do to remain that thing can be cast as a minimization of variational free energy. But the point is that there's no one you, and two, there's no optimal version of you, right? If you developed a psychopathology, you would still be doing optimal Bayesian inference, right? Approximately optimal Bayesian inference, because it's always approximate. But that was just for the model of you with a psychopathology, right? So your priors, the system of your belief, the composition of your beliefs would just be different, but it wouldn't make it worse or better. It would just mean that you're optimizing for a design that was different from how you were before you had your psychopathology. So this is called the complete class theorem in Bayesian design. And yeah, it's just the idea that basically you can just take any behavior and write it down as if it's a descent down a free energy gradient for a specific set of priors. So we can get rid of some of these worries about having to be in a fixed state space, not being able to move, being stuck in dark rooms. There is some flexibility in the free energy principle. That said, whether the free energy principle fundamentally or active inference rests on there being one underlying attracting set for a thing, right? So that you have paths of state over time, and even those are tending towards one underlying dynamic. That's, I think, is an open question. So this is something that I know Kate Nave and Maxwell Ramstead have been talking about. And Kate, I think, again, I don't want to misspeak, Kate's coming on my show, so I'll make sure I ask her, thinks that there's still a fundamental problem in active inference, which is that there's some underlying determinacy, one might say, which is that even the distribution of these paths is tending towards an attracting set. And maybe that's fine, maybe that's not, but it does imply some kind of teleology. You as a philosopher might not care, because you might say, of course it's deterministic, who said it wasn't? But maybe some people might have problems with that.